Welcome and thank you for joining. Let's take a look at a practice question from the dot product lesson, number 17. The vectors a, b, and c are such that a plus b plus c would equal 0. We need to find the value of the expression a dot b plus a dot c plus b dot c if we know that magnitude of a is 1, magnitude of b is 2, and magnitude of c is 3. So let's start off by writing the expression whose value we're trying to find. So we have a dot b plus a dot c plus b dot c. So the first approach that comes to mind is using the dot product formula, which means that we'll have to replace a dot b by magnitude of a, magnitude of b, cosine alpha. We replace a dot c by magnitude of a, magnitude of c, cosine beta. And we replace b dot c by magnitude of b, magnitude of c, cosine gamma. As you can see in this expression, we have all the magnitudes, and we're missing the angles alpha, beta, and gamma. Remember that angle alpha is the angle made between vectors a and b when they're placed tail to tail. Very important. Beta is the angle made between a and c, again, when vectors a and c are placed tail to tail again. And gamma is the angle made between b and c when b and c are placed tail to tail. So in order to determine the angles alpha, beta, and gamma, we have to create a picture of what is happening here with these three vectors so that we can locate where the angles are. Location, we can find the location of the angles. So let's start off by writing the three vectors a, b, and c. So a is the smallest, b is 2 units, so double it, and c is 3 units. So when the sum of three vectors equals 0, that means that the three vectors will connect head to tail to form a triangle, which we call the equilibrium triangle. And this is what it would look like. Now, remember, this is vector A, 1 unit. This is vector B, 2 units. And this is vector C, 3 units. And as you can tell, the vectors are all placed head to tail. That's because their sum equals 0, so the equilibrium triangle. So how about the angles alpha, beta, and gamma? Well, angle alpha is the angle made between vectors A and B. So what that means is that we need to bring vector A with the tail at vector B so that we can see the angle alpha. So here is the vector A with tail at B, and here is the angle alpha. Now, angle beta is the angle made between A and C, which means that we have to bring A and C tail to tail. So if this is the vector A, then we bring the tail of C at the tail of A, and this would be the angle beta. And angle gamma is the angle made between vectors B and C. So we bring the tail of vector B at the tail of vector C, and this will be the angle gamma. As you can see, alpha, beta, and gamma are the exterior angles of the triangle formed by this equilibrium triangle. So if we want to find the angles alpha, beta, and gamma, then we can start off by finding the interior angles in this triangle. And we know that interior and exterior angles will add to 180, so it would be easy to find alpha, beta, and gamma. So how do we do that? Well, if we have three sides in a triangle, we can easily use the cosine law to find out what this angle is. And then once we find the first angle, we can use either sine or cosine law to find the second angle, whichever we want to. And once we found two angles, we just use the sum of interior angles in a triangle, which states that if this is alpha prime and this is, let's say, beta prime and this is gamma prime, so these three angles will add to 180. Okay, so I'm describing the approach just to explain the complexity of it, because as you can imagine, there is quite a few algorithms and quite a few steps that we have to follow in order to solve the problem in this, using this approach. So once you have the angles, you can substitute. And I encourage actually that you pursue this method and check and see what answer you will get. But in this example, what I'm going to try to do is follow a different approach. And in this approach, we are going to work simply with the dot product. So we're gonna start off by writing the statement a plus b plus c equals 0. So we have a plus b plus c equals 0. So what we have in here is the sum of three vectors equals 0. So the next thing that we want to do is dot product both sides of this statement by the same vector. So we will multiply here by a plus b plus c. So we will dot product 0 with a plus b plus c. And remember, this would be a vector, theoretically speaking, multiplied by 0. And the left side of it will also be multiplied by the same vector in a dot product. So dot product, and then we got a plus b, and then plus c. So the statement still holds true because the transformation applied is the same, and it's done to both sides of the equation. So let's dot product the left side of the equation and see what we get. So in a dot product, when we have three vectors, the sum of three vectors dot product in three other vectors, we simply dot product the first vector with every vector in the second set of brackets. So therefore, we're going to get here for a, we'll get a dot a first, and then plus a dot b, and then plus a dot c. Next, we're going to do vector b. So for vector b, same thing, b dot a, b dot b, b dot c. Let's write that down. Plus b dot a plus b dot b plus b dot c. Lastly, we'll do vector c here. So we have vector c dotting every vector in the second set of brackets. So we have plus c dot a plus c dot b plus c dot c. Now, this is the left side, and on the right side, we have 0 multiplying a vector. So we know that based on vector properties, if you multiply a vector by 0, that will give 0. So let's take another look at the left side. So for vector a dot a means that vector a is multiplying itself, which means that we'll have magnitude of a, then cosine of, what's the angle that a vector can make with itself? Well, that's 0. And then we have the next term, a dot b. We are not going to apply the dot product formula here, and that is because we want to keep a dot b in the expression because that's what we are trying to isolate or to find the value of. So a dot b stays as is, and then plus a dot c. So here goes the first, or here go the first three terms. And next we have b dot a, and I will actually write the dot product in alpha order, and that's because I'm going to try to make the terms look alike if possible, if they are similar or alike, and it would be easy for me to recognize if I have a system or an order. So b dot b would be again same idea. So we have magnitude of b, and then cosine of the angle 0, that's the angle made between vector b and itself. And then we have vector b dot c. And we have the last three terms here. We have the terms, the green ones. So c dot a, so I'm going to write this in alpha order again, a dot c. C dot b, I'll write it as b dot c, and c dot c will be magnitude of c, and then cosine of 0. So this entire thing would be equal to 0. That hasn't changed. Now let's check and see what we get here. So a dot magnitude of a cosine 0 would be 1 times 1 times 1, so that equals 1. And next we have a dot b, and I'm going to search throughout the expression until I see a term that is like a dot b. So not this one, b dot c, a dot c, b dot c. So wait a second, a dot b right here. So we have one A dot B plus another A dot B, which makes two of them. So we'll write 2A dot B. So let me try to highlight them. I don't know if I can. It's okay. And then we have A dot C. So let's see if it has any friends here. Yes, there it is. So we got two of them. A dot C. And then plus. Here we have a similar situation. So one magnitude of B is actually 2 times 2 times 1. And we have B dot C, two of them. And then C dot C cosine 0, which would equal 3 times 3 times 1. That's a 9. So as you can see here, we have obtained in here the 2AB, the 2AC, and the 2BC. So this is what we want to bring together, the ABs, the ACs, and the BCs. And not only that, but they have a common coefficient or a common factor. We'll take that out. So 2 times A dot B plus A dot C plus B dot C. And we have the terms, the constant terms 1, 4, and 9. That would add to 14. Take them to the other side. Negative 14. So, voila. We have to isolate the expression A dot B plus A dot C plus B dot C would be equal to negative 14 over 2, or simply equal to negative 7. Isn't this beautiful? So I encourage you to actually follow the other approach as well by finding the angles, substituting them into the formula, and check and see if you get this answer. You may find an answer that is very close to negative 7, so you have to round it to the nearest whole. And that is because when you find the angles, then you never get angles that are super precise, so you will have to round them carefully. So I hope this explanation made sense. Sorry for the coughing. And I hope you find this useful. Try to solve the geometry problems with confidence. So have faith that you can figure things out in one way or another. They can be a little bit daunting at first, but what I would suggest that you do is always draw a diagram and try to connect the simple geometry with vector or algebraic geometry, and try to see these connections. They're real, they're visible, okay? And whatever approach you are thinking of, pursue the approaches, because sometimes even if it is not the actual solution, it is a journey that will teach you other things about vectors, or other things that we can do or things that we cannot do with vector operations, and etc. etc. So again, thank you for learning with me, and bye for now.